Hey, good morning, everybody. So what I'm going to do today is I'm going to talk to you about the Ethereum blockchain. So before I went through and I showed you guys a little bit about Bitcoin, but now what I want to do is really show you about the Ethereum blockchain, because the Ethereum blockchain really provides a lot more functionality, capability. It's more robust, and you're really going to like what we see here. So let's go ahead and get started and take a look. All right. So what we have here is we're going to go through and we're going to talk about Ethereum. We're going to talk about kind of the overview of the project in and of itself. Where did it come from? Talk about kind of some of the founding members, and then really kind of discuss what makes it different from Bitcoin. And then we're going to go in and kind of look at some of the capabilities that we might be able to pull from a technology like this. Okay, so let's go ahead and get started. So when we think about Ethereum in and of itself, where did it actually come from, right? And so there's a gentleman by the name of Vitalik Buterin. And Vitalik Buterin actually was an early supporter of the Bitcoin project. He actually was a co-founder of Bitcoin Magazine back in 2011. And so he got involved in Bitcoin very early on, and was writing for Bitcoin Magazine about the Bitcoin protocol, but he wanted to actually extend the Bitcoin protocol, and also he wanted to kind of do that with a project called Mastercoin, which was really kind of an overlay protocol that would allow you to write smart contracts kind of on top of Bitcoin. And so in October of 2013, his proposal to the team was refused. And so he decided in December to go ahead and start creating a white paper that would kind of define what he would like to build as a new network from scratch, and not just build it on top of Bitcoin. And that was the Ethereum white paper. Now, again, the Ethereum blockchain is a Turing-complete general purpose blockchain. And so that's what we mean by Turing complete, is that we have the ability to run conditional statements, looping statements, and do a lot of the things that we may not have been able to do with the non-Turing complete scripting language that we found in Bitcoin. And so Dr. Gavin Wood was actually one of the co-founders of the Ethereum protocol, and he actually created the Solidity language, which we use in order to write smart contracts. And so that is the kind of high-level language that we use to write the smart contracts that then we compile down into bytecode that we run on the Ethereum virtual machine. In addition to Solidity, there are a few other languages that are available, but Solidity is probably one of the most popular languages for writing smart contracts. In addition to writing them on Ethereum, we also see Solidity being used in other platforms like EOS and so on for writing smart contracts as well. And so in essence, what we wanted to do is with this Ethereum is, again, it's just a combination of new and old tech and inventions to create a distributed, immutable transactions of all types, programmable world state computer that we can all use and take advantage of. So in July, the end of July of 2015, we mined the first Genesis block, or the Genesis block of the Ethereum blockchain, and the world computer came online. So when we start looking at that founding team, there's the few people who are very heavily involved in the Bitcoin space and the blockchain space. So let's just go ahead and kind of recognize these 6 founding members. Of course, Vitalik Buterin, he's still on the Ethereum project. He is definitely, of course, one of the founding members, and probably the founding member, I would say. You see down here in the bottom right-hand corner, there is Dr. Gavin Wood. I kind of thought that was a fun picture because he shows the Byzantium hard fork, which was the first hard fork for moving to Metropolis. So anyway, I'll talk more about that when we talk about what the hard forks were. But anyway, he works on a project called Polkadot, and he also has been working on the Parity and Substrate projects as well. We also have Charles Hoskins, who's to the right there with the beard. Charles is actually one of the founding members of Cardano, and so if you're familiar with Cardano, he created that project. He is on Akasha, which is another blockchain project. Anthony is working with Decentral and Jax, also blockchain projects. And Consensus's founder, which is, if you're familiar with Consensus, very big company, especially with ensuring that you have good smart contracts, creating smart contract libraries, kind of a leader in the blockchain space. They have one of the biggest conferences in New York City every year. And so their founder is Joseph Lubin. And so Joseph Lubin, he is actually also one of the founding members of Ethereum. Cool. So what exactly is Ethereum? Let's go ahead and just kind of revisit that topic again. So again, we said it was a world state computer that's open sourced, right? And so when you think about world state computer, that means that the computer in and of itself it's deterministic but practically unbounded state machine that has a singleton state. So meaning that all of the nodes need to come into consensus or agreement on the state. And so they do that through a consensus method called Nakamoto consensus or proof of work. And so that global state machine applies any changes that you might need to make to any objects that are being stored on that global state. And so the changes are defined in your smart contracts or in the rules that you define whenever you create your DAPPS. Cool. So with that, of course, we can run on that virtual machine, on that world computer, we have the ability to run these smart contracts, right? And so those smart contracts are going to be basically making changes to the state. So when you have objects and you're changing variables or you're changing ownership or something like that, then those are state changes. And so when we do those state changes, we are controlling those state changes and getting consensus on those state changes in a world state. One of the things that I like to talk about when I talk about Bitcoin quite a bit is I say that Bitcoin was a programmable money. I think that Ethereum is more like programs that have money in it. So anyway, think about it that way. So when we start looking at all of these smart contracts, what those smart contracts do is they give us the ability to create distributed applications, or what we call DAPPS. And so those DAPPS have built-in, of course, like I said before, built-in money or built-in economic functions. And by having that, that gives us high availability, gives us transparency, neutrality, reduces our censorship, counterparty risk. There's a lot of things that you can do with this. Things like, real-time reconciliation of your books, right? So that's pretty cool. We can ensure that certain conditions are always checked, regardless. We're not checking every 10 instances. We're checking every instance. And we're paying out based on those checks because that's in our smart contract, right? So there's a lot of really interesting stuff that we can do here. Cool. So let's go ahead and just take a step back real quick and kind of talk about Ethereum and Bitcoin, right? So I mentioned that, Ethereum is more like a program that has, or an application that has built-in economics, right? So money in the program, built-in money, cool. Where we said Bitcoin on the other side was basically money that could be programmed, right? So programmable money. So that's really one of the major ways that I like to look at these and the major differences. So the scripting language was very limited because all we did was dealt with money. But now we're dealing with things that are other than money, so we have to expand that scripting language to be able to accommodate. Cool. All right, so how are these guys the same? Well, they're both open blockchains. They're both on a peer-to-peer network, and they both use proof of work or Nakamoto consensus in order to ensure that we have Byzantine fault tolerance, right? So that's what we see there. And then in addition to that, they both, of course, use cryptographic primitives. Those are just the basics in cryptography that we use in order to provide provenance and immutability and all these kinds of fun things. So things like hashing and zero-knowledge proofs and digital signatures. Cool. And so then how are they different, right? So what makes these guys not the same? These are different. And so the primary purpose of Ethereum is a utility currency to pay for the use of the platform or that world computer. And it's not, the primary purpose of the Ethereum is not to be a digital currency. So remember, right? We have a world computer that has money in it. That's what we got. Cool. And then we have a general purpose programming blockchain that runs Turing complete, not just a scripting language virtual machine. It can run any unbounded complexity, right? So how do we ensure that you don't have a denial of service attack or a DOS attack? Is we simply put measures in place that ensure that you pay for the amount of resources that you're using, and that's done through gas. Cool. So what makes up a blockchain? So what are the actual core pieces that define a blockchain? The components of an open public blockchain are going to be these things here. So we have, now this isn't kind of a hard, you have to have all of these things or you're not a blockchain, but these are generally what the community or what the community as a whole kind of accept as requirements for a blockchain. So a peer-to-peer network, right? That's going to have participants that are going to be propagating transactions or blocks. Those blocks are going to be verifying transactions based on usually some type of a gossip protocol. That gossip protocol in Ethereum is Whisper. And in addition to that, those messages are going to be sending transactions, right? And so that represents a change to any state object that are being stored within that data set. So when we look at those state objects, we see that we want to make a state change, then that requires a transaction. And so those transactions are going to come in the form of a message. So it also is going to have consensus, right? So consensus is our ability to come into agreement, because remember, we're peers and we have to agree with one another. There's not one person in charge, or there's not a central authority. So we have to come in agreement on the state changes that we just talked about based on those transactions. And so in order to do that, we have to have a way to ensure that we agree that the work is good by everybody else on the network. And so that is consensus. And so it governs what transactions can make what changes for valid state transitions or state changes. In addition to that, we have to have, of course, the machine that runs all this stuff. So that's the state machine in Ethereum. Of course, that's the Ethereum virtual machine. And it processes all the transactions according to the rules of consensus. And so when we take those transactions and put those transactions into a block, those blocks are chained together through hashing. And so a chain of cryptographically secured blocks that include transactions, which are just simply the journal that allows us to verify that those transactions have occurred, and we can look at the state and ensure that we can check and read the state at any given time, right? And also we have a consensus algorithm that decentralizes control over the blockchain by forcing participants to cooperate in those consensus rules. Then they're usually, and since we're on a public blockchain, we need to have some type of an incentive scheme that incentivizes making those state changes and ensuring that those state changes are valid and doing them in the correct way. And so, and then we also have, that's what the miners are using. And then we also have to have one or more source software implementations that actually has the ability to use this network, right? So those are going to be our clients, right? And so how are our clients going to get involved? And a lot of times those clients come in the form of a wallet that allows them to interact and spend their ethers. Cool. So when we think about Ethereum and where Ethereum came from, Ethereum came from 4 stages, or it has 4 stages of development. And so the initial stage of development for Ethereum was the frontier stage. And so that was in essence very, very raw, very rough. Frontier is the most minimalistic form of the Ethereum blockchain. It was a command line for merging ethers and for uploading and executing your smart contracts. Your miners are going to can configure and start the mining rigs from the frontier. You could test DAPPS from time to time, purchase ether. But it was basically a safe, decentralized software platform, right? And safe meaning that, kind of in quotes, that safe, based on it is beta software, right? And so this started again in July 30th of 2015, and it went all the way through block number 1,150,000, and that was when Homestead was released. In addition to that, there was also an additional hard fork that came in, and that was block number 200,000, which introduced Ice Age. Now, let's talk a little bit about Ice Age before we get into Homestead. And then also let's kind of just quickly define a soft fork and a hard fork. So anytime you want to make changes to software, since we're in a decentralized environment, you have to come to consensus so that everybody agrees that this is the software we should be running. So if you make a change to the software and that change requires that everybody upgrade, then that's called a hard fork. If you have a change to the software and it's backwards compatible and you don't have to upgrade, that's a soft fork, right? And so that's kind of the difference, right? So hard forks and soft forks, hard forks require that you upgrade. And so I talk a lot about some of these hard forks here because it does kind of require that you upgrade, because there were massive changes to the massive changes to the underlying architecture, and it was important that those changes take effect. And so let's talk about some of those. So the first one that we see here is Ice Age, right? So Ice Age came at block number 200,000, and when we introduced that hard fork, what it did is it introduced where the mining difficulty, so if you're not familiar with the mining difficulty, how hard it is for the miners to mine a block, they were going to take that difficulty, that hardness difficulty, and right now, let's say it's right here, and they're going to just and make it just increase exponentially at certain points in time. And so they're called the difficulty bomb, but in essence, what it would do is it'd make it really hard to mine blocks. And so the purpose of this was so that people would slowly move from the proof of work consensus method that's currently being used on Ethereum to the proof of stake consensus method, which would use a lot less electricity, and there's a few other things there. But for the most part, it's kind of a more economical way for us to come to an agreement, and so it is kind of the consensus method that we're trying to move to with Ethereum. So the Ice Age introduced the hardness for proof of work mining so that we could then slowly move those miners over to proof of stake. That bomb actually got postponed in Constantinople, which I'll talk about here in just a second. Cool. All right, so then the Homestead came into place in block number 1,150,000. And this phase was initiated after Frontier was basically tested and classified by the core developers as safe, right? So the core developers kind of just been testing everything and said, hey, this looks like it's going to be working pretty well, so it looks to be pretty safe. And so that red safe, because it's kind of removed, and you kind of start developing maybe more proof of concepts and really start looking at more business scenarios that could really be leveraging this platform. And so a lot of things happened in Homestead that have kind of left us here at Homestead. We have not yet went to Metropolis. We're not at Metropolis quite yet. So let's talk about some of these blocks that had some really interesting forks. Not too long after the Homestead fork, about 40,000 blocks, 42,000 blocks to be exact, we had the DAO hard fork. And so the DAO hard fork came at block number 1,192,000. And what it did is the DAO was a decentralized autonomous application that was built on smart contracts that had a vulnerability. And it was a DApp, a decentralized application. And the vulnerability that was in the smart contracts of the DAO system allowed an individual to steal, I think, about $60 million in Ethereum. And so the Ethereum developers decided to roll that back, right? They found the vulnerability, they saw that there was a problem in their code, and they fixed it. Well, the community was split. Half the community thought that was a good idea. Half the community thought that was a bad idea because code is law. And so since code is law, even though you made a mistake on your code, on your hash time lock contract, we are going to go ahead and allow that to happen because we feel like the code is law, and even though they hacked the contract, that's just part of the vulnerabilities of the system. And so the people that thought that, and they kind of code is law, that's where the Ethereum Classic came from, because they did not want to give that money back. The rest of the Ethereum community decided to roll the DAO hack back and get the money back to the individuals that lost their money, so that at the beginning stages of this project, it had this massive problem, and if we would have allowed that to go through, then it probably could have killed the project. So they decided to roll it back, and give the money back to those individuals. So that is, you'll hear that term, the DAO hack, or you'll hear it talked about quite a bit, but all it was is, in essence, it was just simply where there was a disagreement among the developers and among the community, and they decided to split. So they did a hard fork that fixed the vulnerability and gave the money back, but some of the community did not want to do that, and they continued to run the same code, and so they did not give that money back, and so that split the blockchain. Cool. So Metropolis is kind of the next hard fork that we're going to be running into. Oh, before I get into Metropolis, real quick, the last block that we just kind of saw, there's a few other kind of hard forks that came in, like Tangerine and Spurious Dragon and Metropolis Byzantium, which you actually saw the fork that was being held by Gavin in the previous slide here. That fork actually says Byzantium on it. So anyway, that was when we first started to introduce the proof of stake model. And so proof of stake is the consensus algorithm specification proposed by Ethereum Research Labs, and it's actually called Casper, which actually is the first letter of all that. So Casper is the proof of stake algorithm. It's actually being ran by the head engineer for that project. His name is Vlad Zamfir, and he's been on Ethereum for quite some time. Not one of the founding members of Ethereum, but he has definitely been around for some time. So anyway, Metropolis is introduced in Constantinople. One of the things that Constantinople did, in addition to introducing a lot of the Casper functionality, a lot of patching functionality, it actually postponed this ice age because Casper's not ready. So I expect to have another fork after Constantinople that will actually bring us into Metropolis. When we are actually ready to move to the Casper consensus method, and we move off of proof of work, and consensus for Casper is ready, and the production network or the main net is actually running Casper, then that will be the final stage of the Ethereum development, and we will be in what we call Serenity. So that's where the expected for everybody to be converted over to proof of stake. The network should be faster, more efficient, easier for beginners, more resilient against mining attacks, and so anyway, that's kind of the stages of development. Cool. So we said that Ethereum is a general purpose blockchain. So what does that really mean? When we think about distributed networks and we think about Bitcoin, Bitcoin is just a state machine that has the ability to track ownership of one currency, right? And that's it. So transactions cause global state changes for that ownership of that currency, but that's it. That's all it does. Whereas Ethereum doesn't just want to track currency ownership. It wants to track the state changes of the general purpose data that's being stored, right? So what is a GP data store? What is a general purpose data store? Anything that has state objects in it, right? So if we want to govern those state changes based on code, then we could do that. And the state is distributed globally. So a store that can hold any data, any key value pairs in a tuple, right? So what do you want to track? And what do you want to have state objects on? And how do you want to own it? That's amazing. Because you start thinking about this and you start thinking, wow, we have data, and we've always known data had value, but now we can quantify it. Now we can actually look at it and see where that value comes from. We can actually start tracking that value. We can actually start giving the value back to the owner that created the data. We can have data ownership, So there's a lot of really cool things that you see being built out on top of this. that's going to be very disruptive over the next few years. So we kind of talked about the different components that are required on a basic blockchain. So how does Ethereum address that same requirements, right? So does Ethereum have a peer-to-peer network? Of course it does. Ethereum runs over the Ethereum mainnet. The protocol that they use is on port 30303, and that is running the dev PDP protocol. The consensus rules that we had mentioned before for proof of work are defined in the yellow paper, and the transactions, of course, are all the individual transactions that are making a state change request that are being sent as a message through the network. So every message is going to have a sender or recipient, the value or the state changes that needs to occur, and any data payload that is going to help to describe those state changes. Since we are making state changes, we have to have a machine that governs those states, and that state machine, of course, is the Ethereum virtual machine. That virtual machine is going to be executing all of the bytecode or the machine language instructions that has been compiled down from your smart contracts. Those smart contracts, or your programs, are going to be written in languages that are going to get compiled down to bytecode. Those languages predominantly are Viper or Solidity. There are a couple of other languages that can be used for Ethereum smart contracts, but those are the predominant two. Data structures. Your data is going to be stored on each one of these blockchain nodes. Those blockchain nodes actually store that data in a database. Yes, you heard me, a database. Not a CRUD database, but a level DB, which actually has some constraints put on the database that removes the ability to do things like updates and deletes, right? And so that's going to have all your transactions, of course, your system states, any hash data structure. All that data structure gets actually stored in the format called a Merkle-Patricius tree. And so we'll talk more about a Merkle-Patricius tree as I start to go through and teach you more about Ethereum. I mentioned before the consensus algorithm is just our way to come into an agreement for the network. So that's going to be the Nakamoto consensus currently, but we are moving to Casper, the consensus algorithm spec that's been proposed by Ethereum Research Lab. And Casper, of course, is proof of stake, meaning that we are going to stake some ether in order to be able to mine a block. And that stake will reduce the amount of contention, which will also reduce the amount of energy that is being used in order to produce transactions on the network. Cool. Economic security is done through ETH#. And there's a lot of clients. I mean, there's Truffle. There's Truffle is kind of for deploying smart contracts. You have Remix for writing your smart contracts. You can do that even in the online IDE in the Remix editor. I'll show you that in one of our next lessons. You have Parity, which is a wallet that you can use in order to interact. You have MetaMask, another online wallet you can use. You have Geth, which is the Go Ethereum implementation of the of Ethereum. So you can, that's probably the most popular implementation, but there's also other implementations of the Ethereum client. So when we look at Ethereum as a Turing complete machine, what is Turing complete? And why? What are the implications of having a Turing complete machine? So when we think about Turing complete, that means that you cannot predict whether a program will terminate by simulating it on a computer. In simple terms, we can't predict the path of a program without running it. Turing completement, or having a Turing complete system, gives you the ability to have an infinite loop because you can't predict the outcome, right? It could just run forever. And so problem is how do you know how long a program or smart contract's actually going to run? And so that's where we run into things like gas, right? We kind of mentioned that earlier, but when we think about a denial of service attack, we could just say, hey, I want you to do this, and it'll just run forever. Well, how do we keep it from running forever? Well, we can pay for running. And so that's how we do that. We just say, hey, if you're going to run, and you're going to run what I'm asking you to run, then I got to pay for it. And that's gas. Cool. Gas can only be purchased by an individual that's requesting a transaction to be computed. So I can't just buy gas for no reason. I have to buy gas for the transaction, right? The transaction that I'm running. And so if the transaction that I'm running runs out of gas as it's trying to do that transaction or do all the computation that's required in order for that transactional state change to occur, if it runs out of gas, then that's the state of that object will roll back to zero. It'll roll back to what it was before it started, right? So no changes will occur, but the gas that you paid will be gone, right? So it's important that you pay enough gas to be able to fulfill the request that you submitted, or else you'll lose your gas, right? And you'll lose your money. In addition to that, if you send too much gas, well, there's a problem there too, right? So if you send too much gas, well, what happens to that gas? Well, that gas actually comes back to you. So that's pretty cool. So if you do send too much gas, any gas that's not used by that process will be returned to the sender. Awesome. So if the transaction runs out of gas before it completes the state change, the object gets rolled back to its initial state. Awesome. All right, so all of this smart contract, all of these requests, all these state changes, this is all so that we can build what we would consider a decentralized application. What is a decentralized app? Or a DApp is what we usually refer to it as. It's basically our next generation of applications. So when you start thinking about how are applications built today, applications are kind of, centralized. It's on your machine. It's not, there's no decentralization. So Ethereum is really kind of trying to become the platform for writing and programming a decentralized app based on those smart contracts that we created earlier. So it's a broader perspective of the smart contract. It's actually taking the smart contract in and of itself and then writing an interface so that we can interact with that smart contract. So that the user can have an application that they're using and can actually start doing stuff, right? So there's a web application built on top of it. And so a DApp is going to have, the smart contract, which of course is the back end. It's going to have some type of a front end user interface or UI. And then a lot of times you're going to have some type of a storage. You're going to have to store some data, right? So you have to have some storage protocol like Swarm or something. And then you also have to have some messaging protocol to send the transactions back and forth, like Whisper, right? So Whisper, Swarm are two protocols that we have in Ethereum that provide the PTP storage and messaging functionality. Cool. So with all this stuff, right? So let's kind of wrap this up because we've been talking for a while. But with all the stuff that Ethereum's doing for us, how is it going to affect you, right? So let's look at the Web 3.0 functionality that we hear about quite a bit, and what exactly is Web 3.0, and will Ethereum actually be kind of the one that provides a lot of this functionality to us? And I think it will. So let's take a step back and think about when Web 1.0 came out, right? So back in the 90s, or the first time you ever got on the internet, whatever, back in the 90s when it first kind of got started, then we were consumers, right? And that's it. We would consume data. What do I mean by that? We didn't produce anything. When you went online, you would look at pages and you would ingest those pages. You did not post anything unless you were a web developer or unless you were actually a web host or something like that. You weren't producing anything. You weren't publishing anything. You were just consuming. And so in Web 2.0, we kind of seen a shift in this, and we saw a shift in our applications that gave the applications the ability for consumers to start doing publishing, so self-publishing applications. And so these were things like YouTube and Twitter and Facebook and social networking and so on and so forth. But in essence, we can start putting our opinions out there to be consumed by others. And so now it kind of, before that, if you wanted to be published and had people read your stuff, you had to go through a publisher and a clearinghouse, or you had to get a record label, or depending on the industry that you were in, to get that kind of exposure to get published, you had to jump through hoops. Now, Web 2.0 kind of lowered that bar, right? And it allowed us to publish data much easier. And so with Web 3.0, what we've done now is we've created applications that can migrate from a centrally managed application to a decentralized protocol application. So in essence, the application is a kind of like just a service, right? And so when you start thinking about how is an application going to be delivered to you, traditionally, if we were going to go buy software, buy an application, we would have to make a capital expense. And that capital expense would come in the form of buying a license that was a version license, or it would come in the form of buying a license that was an agreement on a subscription. So maybe I bought an Adobe subscription for the year or something. So when you get locked into those capital expenditures, it gives quite a bit of waste, especially when you may only use that application, once or twice a year. And so the capital expense doesn't really justify itself very well. What if you could just pay for the usage? Kind of like what we're doing with Ethereum. Pay as you go. Pay for what you need. Lock in the cost when you buy the gas, right? Or something along those lines, right? So we give you kind of the ability to with Web 3.0 is we give you kind of the ability to kind of have applications that are more publicly available, very decentralized, and open sourced, right? And so in addition to that, you'll also see where we're going to have data sovereignty, right? And so where individuals, because if you build applications like this, individuals should be able to own their data. And that data should not be centrally stored, or anytime that data is accessed, we can have control over that. And so I think a lot of the Web 3.0 apps are going to start to give ownership of data back to the users. And then we see people complain about that with Facebook. We see people complain about that with their health records. And so a lot of these Web 3.0 apps or 3.0 apps are going to be able to help kind of mitigate that functionality. Cool. All right, so let's wrap this up. I think we're getting kind of towards the last few slides here. So with that, let's look at the Industry 4.0, or what we call the fourth industrial revolution. And I think that this technology is really going to ramp us into there, and I'm going to kind of try to explain to you why I feel that way. So that fourth industrial revolution, if you're not familiar with the first three, the first one was kind of just mechanization, where we started to use steam power and water power and generation, stuff like that. Then we did mass production, so that was like in the mid 1800s. Second industrial revolution, that was of course when we started to do the production line, mass assembly, and interchangeable parts, stuff along those lines. That was kind of like the Henry Ford early 1900s. Then we started to use computers and automation. This started happening in the 80s. Of course, it kind of brings us up through today. And now what we're moving in is we're kind of moving into more of a ubiquitous computing environment where the physical systems and the cyber systems interoperate with very little requirements or assistance required from a type of manager or human interaction. So this is an Industry 4.0 is basically the name that's given to the current trend of automation. And so there's a lot of technologies that are going to allow this to kind of come into play. Blockchain is kind of the back end piece that is going to allow this. But if you start thinking about the middle layer, you have things like AI and machine learning in that middle tier. And then when you start thinking about the front end, you start thinking about, okay, how is the user going to interact with this? So this could be, with alternate reality, virtual reality, gestures, movements, natural speaking. That's all your front end computing pieces, right? And you could also have IoT devices that are actually bringing in data through some type of a sensor on the front end as well. So Industry 4.0 is in essence basically creating ubiquitous computing everywhere, allowing computing to pull truth from the environment really any way, anytime, anyhow, right? And so I think there's a lot of cool things that are going to happen with this next, this fourth industrial revolution, and blockchain is just kind of the first step to that, because that's the back end piece, and then we have the middle tier that we're going to layer on top of that with AI, and then the front end is going to be your AR and your alternate reality and virtual reality and stuff like that. So really, really cool time to be involved in technology, because I think that we're poised to see a massive disruption here over the next few years. So when we start looking at Ethereum and why do people kind of gravitate towards Ethereum as a blockchain solution? Well, one is that it's an environment that's built by developers for developers, right? And so all of those guys that we saw, they were all coders, right? Charles and Vitalik and Gavin and all those guys, they're all coders, right? And so they built this platform for developers. And so in order for you to be kind of efficient in this realm, it's difficult. It's not easy. And so, you have to have a multitude of skill sets in order to kind of get involved in Ethereum. And so Ethereum tries to make that as easy as possible, but when you start thinking about all these skill sets, you probably are deficient in one. You may not know economics, for instance, or you may not know cryptography very well. So it's important, that you kind of try to, it's hard to bring all of these skills together and build one environment. The Solidity language is, again, it's kind of influenced by C++, Python, and JavaScript. It does target the Ethereum virtual machine specifically. It was written specifically for the Ethereum virtual machine. It is object-oriented, language that we use for writing our smart contracts. And so we'll be doing a video on Solidity here soon. So I hope you guys enjoyed this quick introduction to Ethereum. I wanted to just give you kind of a reasons why Ethereum is really so popular, and really just kind of discuss some of the interesting concepts of Ethereum. I'm actually going to be taking my Ethereum developer exam here in the next few days, so I was hoping that I could kind of touch up on some of my skill set by putting this little slide set together for you. So I hope you guys have enjoyed this. If you need to get in contact with me, I love teaching. I love helping. I am an independent consultant and contractor, so I will, I don't mind begging for your support. So yeah, if you need some help, if you want to reach out to me, if you need me to educate your team, if you want to get some training, reach out to me. Here's my email, and there's also where you can find me on LinkedIn. All right, I hope you've enjoyed this training, and we'll see you guys next time around. Let's give us a thumbs up